Boom, we're going. So, good evening, everybody out there in digital land. We got a couple more people joining now. That's cool. I just want to go over the final exam, which is located under your course lessons, all the way at the bottom. Final exam. It is total of 50 points. There's a practice exam. It's 35 questions at your leisure. Open book exam, right? The final exam is 20 points, 50 questions, 50 minutes. It's open book as well if you need it. Use the time. Got a minute per question. That should be pretty good. Relatively, I see a lot of hundreds on this. Like I see a lot of 20 points earned most of the time. Now the final lab, it's not that one. It's this one. The final lab is a trivia game. Make that a little bigger. First two paragraphs will go over what we expect. Give the user a welcome screen. Welcome to the trivia game. Give them directions on how to play the trivia game. Because the last couple of weeks, some of the things we covered, it's just like an abbreviation. Or give me. It was very cut and dry what a lot of folks did. Give the user directions. When you write your directions, it almost documents your code for you. So that's one of those prime things that you want to get in the habit of doing. Because what will happen is you'll write a cool script that does some automation for you. You'll go back to it months later and go, what was I even thinking? I don't even understand how to use this myself. So write directions, write good comments, comment the why. If you're going to print something out the standard out print on the next line, don't comment that you're printing out to the screen. That's obvious, right? You could read the code. Print the why you're printing it out, right? There may be some need to put this data out on the screen. Jan from finance requested that this is printed out at this point. Some reason. Try to fit it in a requirement. But if you wrote a good lab 5, the rock, paper, scissors, you could use that as a template for this one. Same type of requirements, mainline logic. That implies the use of custom functions. So write at least one custom function, which would be your main function, right? Error handling, try accept, header, that's in the template. Comments, be wise with them. Give some good, comment to why, once again. The slashes are ors, global variables. Some may use both. Some of you may just choose to use globals. At least one custom function, like I mentioned. Use of a list, tuple, or dictionary. One of those, or if you want to solve the problem with a dictionary and a list, go ahead. I'm not limiting you to just one. I'm just saying I want to see you use at least one of those complex objects. And a looping function, a while or for, right, which is pretty common. Then the rest of this is just 5 basic starter questions, but you could develop your own game. I had people do Lord of the Rings, Star Wars, favorite TV shows, sports. Different is fun. How you ask the question, how you present the multiple choice, or do you have them type in the word? It's up to you. Now, keep in mind, if you do multiple choice, don't have all the answers be D and like really easy to code, and put some thought into it, have some fun. But flex. This is where you want to show off. It's 30 points total. Pretty clean scoring right here. Not too many things to do. Which brings me to the naming of the script. I popped it in the announcements, so everybody has it in their email as well. 2252, last name, first initial, final, pi. That's it. Your last name and your first initial, not mine, because I've received some of those before. And that's it for the final. Got plenty of time to turn it in. It's been available all week since the last time we met. I turned it on that evening, and it has to be in by 11:59 on the 16th. So you still got a couple days to work on it. But hopefully everybody watches this and you're well ahead, and You know, everything should be good from your lesson 5 to now. So there's no use of files, though you can, if you choose to put your questions and answers in 2 separate files and read them in and compare, go ahead. You know, this is where you want to test yourself. And that's it for the final. Any questions? No? Cool. So, Steve, you want to talk about some functions, huh?
Yes, please.
Functions and parameters. Let's take a look at this. Okay, so this is something called a class. So I want to discuss what a class is too. This is like moving on to intermediate Python. This is like where the kind of the fundamentals end and where you start to like stretch out for intermediate Python. So during this course, we've used different types of objects, different types of built-in objects, lists, dictionaries, tuples, strings, integers, couple other different ones. But what if there's an object that you need that Python doesn't have, right? Well, I gave the analogy of a container and the class being container, and then the type of container could be water bottle or Tupperware or something like that, and then you build these parameters or these methods or functions or attributes about that type of object. It's relatively simple. Like in this instance, it's just the key term class space, then a variable name. In this case, I called it user, and with a colon. And then underneath it, you define things just like your regular functions. This double underscore init double underscore has a special meaning instantiation, and it's the initial instantiation of an object. So that's a fancy way of saying develop an instance of an object. You could have more than one cup, right? Like this would be class cup. One's a coffee mug, one's a regular glass. They're both cups. They're different. They're 2 different instances of the object, right? They exist separate from each other, and they have different attributes, but they're both the same type of object. So here we have a user, but you notice we use the definition statement, and then we define methods, and then we give it parameters. And then within that function, just like regular functions, we could do certain tasks. Here we're splitting, calling on indices, all kinds of fun stuff. So we'll talk more about some parameters and functions. I wanted to introduce what a class is and what the method of a class is, just nothing more than a function. Now, how do you use them? How do you leverage them? Well, here I'm going to do just a variable user1 equals user. You call on the class name that you give it, user, and then see how this says self. That means it's going to be its self instantiation. So this variable or this argument is skipped, and you get full name and birthday. So I give user, I call on user, I give it my full name, Zach Wojton, and then my birthday. Cool. Well, what does this buy you? Well, you could use user 10,000 times, 100 times, it doesn't matter. As many times as you wish. For those of you who play like multiplayer online games or any video game for that matter, and your character runs into a room and there's 5 or 10,000 of the same bad creature or bad individual character trying to harm you, but each has a different health rating, those are instantiations of the same object, of the same character, but each of them have their own health bar. Same thing, right? So here, we just variable user, my son's name, Liam Wojton, another birthday, and then we start to print the birthday. Toot, 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 toot. And when you print the user 1, You see that's an object and you'll get like the memory location of it. And now when you start to call on attributes of it, like self.name equals full name. So the object dot name equals full name. There's my full name. Birthday, birthday. But now within this function, I split the full name, store it in name pieces, split on a space. So now I have my first name and last name. And then I'll call on then this is just a made up method, first name, and I'll call on the indice of 0. So I'll get Zach. And then here I call on the indice of -1, which goes backward, grabs the last index or item in the index, which is the date, or my bad. I split the name, not that. It's been a long day. So this turns into a list. 0 is Zach, going -1 is the last name. So now I can call on those pieces individually. So technically, with one piece of information, someone's full name, you could carve it up and get the full name, first name, and last name. So you can have 3 items from getting one piece of information. The birthday is a little trickier. When you grab someone's birthday, you get a ton of information. And I don't know, have you ever put into how much thought you get when you get someone's birthday? Anyone? What do you get when you get someone's birth date? Well, here's a crazy thing. Yeah, hit me. Anybody have something they want to say?
I was going to say 1 zeros, but I don't think that's not the answer that you're wanting.
Well,
It could be several combinations too with a birth date.
yeah, totally. And the awesome thing is when you get a birthday from one user and another user, you could do things like how many days apart are they? Days. Mathematically, you could do years or days to see age groups of your users. How many days from now was it to their original birthday? So you know how many days they've been alive, so you have their age. You also have like special events. We'll say like from the moon landing. How many days old are you from the moon landing? Well, you are days old from the moon landing because you were born after that year. So you could do all kinds of wild date math. But you also know if your birthday's around Christmas, if your birthday's not around Christmas, you could tell a lot of bizarre stuff from just someone's birthday. But you could do a lot of trending like that, and that's kind of cool stuff, right? Think Facebook having like everyone's birthday. That's like insane amounts of data. They could tell you right now if you say, "Hey, when Reagan got shot, when his attempted assassination happened, how many people in Facebook were alive then, and how old were they?" You could do crazy data like that, right? Like really cool stuff. But you'll probably never look at a birthday the same. I hope that's the whole goal of this, right? Let's take a look at this. So we're going to get into that a little bit. So here, function, parameters, all this fun stuff. Well, we're going to give our class user another function called age. Self is not a parameter. It just means when you put it user, like user, this variable named user, that is the self. So when you call on age of user, it'll perform these tasks on the birthday. A little bit confusing, but think of it as call it like if you had user 1 and user 2 here, if you did user 1.age, it's user 1.age of user 1. And if you did user 2.age, it would be user 2.age of user 2. It calls on itself to get the data that it wants. And age is derivative from the birthday, and we imported date time. awesome module. I suggest everyone spend a little time and check out, if you plan to move forward with Python, check out date time. It's awesome for time stamping. It's awesome for doing some date math and all kinds of stuff. Here we chop up the birthday into the year, month, and day. And we have the full, which is date of birth, but we replay it. We call on datetime.date and we give it the year, month, and day. Age and days, today minus date of the birth, and we call the days function. So you get how many days, then we divide it by 365 to get in years. And then we return the integer of age and years. Back to functions, right? In this case, this is a method of a class, which is basically a function of a class, right? So this function of age will return the age in years. But when you see down here, we just say print it. When we say print user age, it should return it in years. Let's see if that works. Boop-a-doop-a-doop. Yep. So we got print user, we get this joker, the full name is that, the full birthday is that, first name, last name, and then when we call on age, it goes age user.age user, and it uses this schema, breaks it all up, performs all these tasks, performs years and age, and it returns it. It returns as an integer. So when we call on the age method, after the math, we get 45. And then we throw in another user, user 3, Ed Snowden, his birthday, call on that object's age, and we see it's 52. So each object leverages this function. Now, remember what return does. Return, you could take multi-values here. If I wanted to return age and days as well, I could add it after the end. And usually what we do is we store it in a variable. And then we can pass that variable to another function. So if I wanted to do something with age and years, and I call on user age and years, instead of print, well, what I'll do is I'll just do this. We'll keep that there. And we'll say user age equals user age, right? Well, now that I have their age stored in user age, I could do all kinds of stuff with it. I could subtract what the last Halloween was. I could do anything I want. Now, when we call on user.age, it's going to be user with this date. It's going to return in years. So I can just put years right here. And now this output of 45 will be stored in this variable. And then if I had another function, let's just write another function really quick. Out of the class, we'll define a new function, and we'll call it add 10. It'll take X. Oh, my bad. I always forget about that. We'll say add 10, and it'll literally take, we'll say Y equals X plus 10, right? We'll do that, and then we'll return Y. So we got this joker, age, being stored here. And then we're going to call on our add 10 and pass it our X, which is the age in years. And it's going to return Y. And we're going to store Y in plus 10 equals, and then we'll print plus 10. Capital P. Yeah. See if this works. So now we're back to here. That's right here, 45. We call in the same method. We store 45 in user age years. Then we pass user age years into our new function called add 10. It takes the place of X. So in reality, we're saying 45 plus 10 stored in Y, 55, return 55. 55 is stored in plus 10. Then we print plus 10, and there's our new age plus 10. Does that help kind of for passing parameters between functions, Steve?
I'm looking to see where you got your plus 10. I see it
Yeah, right here.
there, but when you spelled it out as a word, as like a variable down here,
Mm-hmm.
okay, never mind. I just answered my own question. Yeah,
Yeah,
I see it now.
yeah, you stored it in a variable, right? So it's almost like one extra step is if you were to say it out loud, right? It's like, I'm going to take their age, add 10. Okay. But what we're not saying is I'm going to take their age, add 10, and store it in Y and return Y. And then Y gets stored in plus 10.
Yeah.
Yeah.
Yeah, I see it. Thanks.
Yeah, no worries. Being able to pass parameters like this it's a lot of fun. You can do some pretty cool stuff with it. I think in the next example I have a let's see, a pretty robust. And we're just building on this one class, right, of user. So now, just like functions, triple quotes is a documentation string. So if I were to get help on user, this would show up in the help, which we'll do in a second, right? Same thing, builds the user, grabs her name, splits it up in the individual names, age, cuts it all up, returns age in years, has another function called D in days, so date or however old they are, age in days it should have been, returns the age in days. So sort of what we just did, except just flip it around a little bit. And now you see right here, we print the user, we get this, call the name, birthday, first name, last name, first name, last name. And now we say help on user. And you notice this is a doc string. Good habit to create this section. I should say section when creating. I'll just change it right now. Section when creating classes. And right here, here's our doc string. This is the doc string. Notice it's right here. So when you document your code, when you use a class object, it sets up the parameters for you to document your code when you call on help. So all you have to do is throw it in triple quotes and walk someone how to use your new object you built. Let's see, then we got where we at down here about method. So the methods that are defined here, you notice that it finds init, age, and D in days. You gain some self-help and self-documentation when you use a class object. So how could you use a class object? You could say class object quiz answer, and you could build an object with your question, 4 answers, and then one of those 4 being the right answer. So you could use a class to actually build your quiz if you wanted to, right? You don't have to. This is just like a bonus lesson, but classes are pretty cool. And the cool thing about it is you can create multiple objects. Here we have user, which again is me, and call it user 3, toss in Ed Snowden, and we get how many different days. Of course, user 3 Ed Snowden is 52, and he's 19,000 days old, and I'm pushing 17,000. So you can do all this fun math with date time as well. But this is a very brief introduction to the form of Python that you'd move forward to from this course, and it would be leveraging classes along with everything else you've learned up until now. Because literally everything we covered from lesson 1 through 7 could go underneath a class just fine. And you can do this without building a class, but your script would have to loop through everything over and over and over and over, and it would become time consuming. Here, when you call on your objects, they already have all that done for them, because the minute you instantiate them, you create the object, it gets all those parameters at birth. So it's kind of a cool benefit. And like I said before, going back to the multi-online player game, when Leroy Jenkins, when your character walks into one room and you have 10,000 of the same character to defeat, but each have their own health bar, that's a class of object. Class, object, enemy, what type, elf. Elf has 5 power level. So every elf it creates, and you do elf times 10, you have 10 elves, they all have the power level of 5. You hit one, goes down to 4, everybody else still has 5. Because they're individual objects in memory. Isn't that cool? Never look at a game like that the same, I hope, either. You ever get lag? Like, well, not when you're playing online, but when you're playing it on your own, and your screen is filled with all these enemies, it's like chugging along, like chug, 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 chug. It's because each of those little objects takes up an instantiation of memory. And as you defeat them, the game kind of speeds up. It's kind of wild. Exactly how it works. Throw more memory at it, right? But this is just a quick rundown of what a class is. We kind of jumped the gun. I kind of skipped over the boring parts of building real simple ones, and we went right for the gusto. And there's a couple other things I want to cover. So let's take a look here. So we've been doing a lot of like individual functions by themselves, like one function that does one thing and does it very well. Well, you could have inner functions. If you call on this outer 10, right? Well, number 1 is passed to this inner function, so that's 10. Outer 10, inner increment 10, return 10 plus 1. Number 2 is a variable we defined inside our function, equals inner increment number. So this doesn't run yet. It's just defined inside our function. Once we define these two, and then we call on outer with 10, inner increment 10, inner increment 10 plus 1, return your number, which is 10, plus number 2, which is increment plus 1, is number 2. So you get 10 and 11 back. And here we go with our 10 and 11 back. Cool. Sometimes you necessarily don't have to nest your functions. I'm trying to think of a time when you absolutely have to, and logically there's other ways to get around it, right? But this is a pretty simple function. Don't you agree? Just adding 1 to a number, maybe not function worthy.
Yes.
But you might have to do it over and over and over and over, right? Well, this is just nested functions, but in walks lambda. Lambdas are functions that you don't define. So what do I mean by that? It's an expression. Definition is a statement. Your lambda is going to perform an action, right? So here's a function that we normally call on, right? Function 1, 3 parameters. And with those parameters, we're going to add them all together, as long as they're integers, right? So here we say function 1, 173, 173, That should be 11. We'll get it. I'm just going to save it, hit run it. And we get 11 right here. That's this line right here. Let's talk about lambda. Lambda is an expression. So what does that mean? Lambda literally takes values followed by a colon and then an expression. So if we say x equals 1, much like we did up here, y equals 7, and z equals 3, colon, x plus y plus 3, and have it in total, and we call on total, we get 11. Lambdas are, they are functions in reality, but they're simple functions that do one thing very well. You know how you can write a function and keep going in your statement and get real wild with it and like tear it up and turn it into 10 different things like our birthday? You really don't want to use a lambda to do that. It's not that efficient. But if you have to do this over and over, now you have total and you have your lambda right here. Well, if you took your variables and x equals, we'll say v1 equals 1, v2 equals 3, and v3 equals, I don't know, 7, right? Well, now we could replace these with, we'll say x is v3, y is v3, and z is v1. And now this is how efficient a lambda is. It said 7, 7, 1, 7 plus 7 plus 1 equals 15. Lambdas are really quick and efficient, awesome for doing one expression without defining a function. You can get wild with these. In other words, you could use this as a argument inside a function. Not best practice, but you could. You could use this right here to perform that addition, store it in a variable, and then print it out. Lambdas, there is a time and a place for a lambda. If you find yourself going, man, I just need to do this simple expression, I don't want to design a whole function and call on the function and pass everything, don't. Right in line, you could put a lambda right in line. So you never have to leave your function to call on another function to bring it in. You could do it right in line in your code. I know they're kind of tricky, and I know I'm just touching on them right now, but the more that you progress in Python, the more that you'll find yourself going, man, I can just use a lambda instead of defining a whole function. Isn't that kind of cool? It's kind of cool. I think lambdas are pretty cool. What else we got? We got with, of course, but I want to go over this again because it was kind of brushed over it. Let me remove that. Remove this. So the with context, it's with some expression as a variable. I know that sounds kind of funky, but you're going to see it in action. So how do we usually open a file? Well, file in, open, call in the file name, append, what mode you want it in, perform some action to the file that we just opened, and then close the file. So it's open, perform action, close file. Pretty common, right? What you gain with is a free close. So with open, file, what mode, as your variable, so as fin, then you notice it followed by a colon and a tab over. So now this is the script block of the with function. So now you say fin.write, do this. There's a hard return. It goes back to the left. It closes the file for you. So one could say the syntax is a bit we add with and as, but we don't have to do a close statement. Could be beneficial. Well, if you had to do a bunch of stuff to this file, like write 100 lines, remove one, find something in it, and replace it, you can do that along the way. And then you don't have to worry about closing it, because as long as you go back to the left and exit that with statement clean, it'll close it for you. So, and this is also like the newer way. They introduced this, I can't remember, Python 3.4, 3.6, I think. And it just saves you from typing that close. You mean to do it anyway, sometimes overlooked. Boop, boop, that's it. Boop, 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 boop. We used with, but it didn't burn out right. I don't even know if I have that file there. But at the end of the day, that's the fun with, right? But yeah, any questions on with Lambda, or kind of just brush over what a class is or parameters? Awesome. Anybody have any questions on the final? None so far? Good. Does anybody have any questions that you want to ask if I turn off the recording? I'll do that. Well, I'm going to go ahead and end the recording. I want to say thanks to everybody before I do that. It's been a real fun semester so far. Get your final in. If you're missing any grades, send me an email. I'm going through my emails over this past week. A lot of people have been missing a couple things, and I've been grading them as I go. I'm catching up on my email. I should be caught up by Thursday night, tomorrow night. So if you already sent me an email, I'll have it up to date by Thursday night. If you haven't and you need me to check out a grade or something, send me an email and I'll check it out. Just be safe, have fun, enjoy the holidays. And that's it for the recording.